Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aziz bin Muhammad Zaki and I will explain about the Lab 4 Infinite Impulse Response FIR filter design. Okay, first of all, let us know about what is finite impulse response. Okay, in signal processing, a finite impulse response filter is a filter whose impulse response or response to any finite length input is of finite duration because it settles to zero in finite time. In the common case, the impulse response is finite because there is no feedback in the FIR. A lack of feedback guarantees that the impulse response will be finite. Therefore, the term finite impulse response is nearly synonym with no feedback. Okay, that's for the synopsis of FIR. Let's go to the procedure, which is this one. The procedure tells us to plot the exact plane and the frequency response using MATLAB, and the C part is using Simulink. This is only question about the characteristic. As you can see, this is the system impulse response vector are as follow, which is H1, H2, H3, H4. So the first one we will do for the Z plane at the MATLAB. So this is the coding for the Z plane of each system. And if we run, we can see the H1, H2, H3, H4. This is follow directly. Okay, this is the graph for H1, this is the graph for H2, and this is the graph for H3, and this is the graph for H4. Let's move on to the next question, which is frequency response. On the question, they ask for frequency response for each system. So this is the coding, and we run to see the result. Oh, okay. Okay, this is the graph for H1, H2, H3, H4. We can see it almost the same as the first one. Okay, let's move on to the Simulink. Okay, on the Simulink, this is the schematic capture for FRR filter H1. They already give, and we just follow as given. This is the setting for sine wave. This is the setting for unit delay and gain. And this is setting for scope and spectrum analyzer. So we just follow as the figure shown, and we run. As you can see, this is the graph of spectral analyzer before FIR filter. So this one is the graph after FIR filter. This is the graph for scope 1, and this is the graph for scope 2. Okay, let's move on to the H2, which is this one is the schematic for H2. This is the graph for spectrum analyzer before filter, and this is after filter. This is the graph for scope 1 and scope 2. For H3, this is the schematic diagram, and this is the graph before filter, and this is the graph after filter. This is the graph for scope 1 and scope 2. And lastly, H4, this is the schematic diagram. This is the graph for before filter, and this is the graph for after filter. This is the scope and scope 2. Okay, for the question, determine the filtering characteristic of the above filter. First is low pass. For the H1 is low pass. For the H2 is band pass. For the H3 is high pass. For the H4, band stop. So in conclusion, we're ready to comprehend the essential ideas and working standard of the FR and IR channel. Next, we figure out how to comprehend the structure of the FIR and IR channel. At that point, we're ready to comprehend the ideas of certain essential FIR and IR channel plan strategies. Ultimately, we can see the ability of planning FIR and IIR channels to meet certain shifting necessities. Okay, that's all from me. Thank you.